All right. Hello, everyone. Welcome to Bytetalks, another episode. Today, I have Danny joining us, and I'll let him introduce myself, or let him introduce himself. Well, it's great to have you. Thanks for joining us, Danny.
Thank you so much for having me. It's a pleasure to be here. And yeah, hi everyone. So my name is Danny. I am a data engineer by trade. I have been working as a data practitioner for a decade now, I think. And I am currently working in marketing at Estuary. And I do a lot of developer advocacy. I write a lot of documentation. My main mission is making sure that our users and our customers are having a good time and know what to do, and essentially just enabling them to be actually productive with the platform.
The developer advocacy is a noble pursuit. You help
It is.
make everyone's life easier. Awesome.
I try.
Yeah, so for people who don't know Estuary, that are listening, what is Estuary, and why should they care?
Yeah, so Estuary is the name of the company, and the Estuary Flow is our flagship product, which is a unified ETL platform. Unified meaning that we do both batch data ingestion and real time as well. We tend to focus on the real-time use cases, but there are some data sources that only support batch integration, like SaaS platforms like Salesforce, or actually Salesforce has a real-time connector, like HubSpot, I don't know, and some other ones. So what we do is we capture hundreds of sources from all of these operational databases and SaaS platforms, and load them into analytical data warehouses, or provide them in operational analytics use cases, or we also do some real-time transformations as well in flight. So it's a little bit of a mix of ETL and ELT and batch and real-time.
So could someone adopt Estuary as like their full data platform solution? Like, is that or ETL part of the data platform?
Oh, well, it depends on the use case. We would like to get there one day, for sure, but there are still a few components missing that can be probably done better if you have like a actual data warehouse on the other end.
Okay, cool. And so Danny and I have been speaking for a little while because they were coming out with something new that was interesting for us at Bytetalks in the stream processing space. So you want to share what that was?
Yeah, definitely. So we just recently launched Decaf, what we call Decaf, which is our Kafka API compatibility layer. Whew, I managed to say it properly on the first try. It's such a mouthful. Yeah, so historically, we've been more focused on integrating data into analytical platforms. A very common use case was an operational database powering an application like Postgres, MySQL, MongoDB, and we change data capture, we extract the data and load it into something like Databricks or Snowflake, or something for more historical analysis. And with Dekaf, we wanted to enter the Kafka ecosystem, essentially, because that's where all the real-time fun happens. So with Decaf, any tool, any technology that is able to read data from a Kafka topic is able to consume data from Estuary Flow as well, without any setup required, without any additional configuration. You can just create the data ingestion connectors, spin those up on our end, and start capturing data from Bytetalks, for example.
Super cool. Yeah, and we use Kafka. Well, our community, Kafka or Kafka API compatible systems are kind of the most common systems to use with Bytetalks. And mainly it's because you get this idea of replayability, so you can track your progress and replay things, which plays really nice with stateful stream processing because you want to know like, hey, this was the last good known place. Let's go back to there and start processing for there. So it really opens up lots of possibilities to integrate things you do with Python, I guess, like machine learning and AI, and analytics with Estuary, which is kind of cool.
Exactly.
Right on.
And
Do you want to? Yeah,
the
sure. Go ahead.
biggest challenge in this whole feature development was that Estuary Flow is not based on Kafka. So I mentioned that it is a real-time and batch processing platform, but the founders of the company opted to not build the whole thing on Kafka because Kafka is not really ready, or was not ready, and we believe that it's still not really ready for the cloud-based world, and to be used at scale for easily used at scale. So learning from Kafka's mistakes, they created Gazette, which is the open source framework powering Estuary Flow. And so the thing that the reason that I'm mentioning is that because to create the Kafka compatibility layer, we had to essentially mimic Kafka's API and implement parts of it instead of just letting people use our Kafka broker, which doesn't exist. So it's been a tricky ride.
It's like a proxy, sort of. It's like a proxy.
Yeah, exactly. So Gazette has some similar primitives. So Gazette has a bunch of similar primitives as Kafka does, but they are called a bit differently. So instead of topics, we have like journals and so on and so on. There can be parallels drawn, but we didn't have an API that Kafka consumers could connect to by default. So we had to implement a proxy API, translate those requests, and just tell Gazette that, oh, if somebody wants to look at, I don't know, 5 documents at this offset, then in Estuary Flow language, that means that you should get these. So that's why it was technically challenging, but we got there and it works well.
Yeah, it's really impressive. I mean, the Kafka API has this like quite a large surface area to cover for compatibility. So because there's tons of little knobs you can tune. It's like if you go look at the like configuration parameters, there's like 100 of them, like the consumer alone, and you're like, okay, now you have to somehow manage to work with those, or deny them and say why. But it's really impressive.
Exactly.
You mentioned cloud ready. Well, I have 2 questions that came up. But first, you mentioned cloud ready. So, like, what does that mean for people who are listening? What does that mean that Kafka's not cloud ready? And I think there is an acquisition they did that proves that Kafka really wasn't cloud ready, and that's why they made that acquisition. But tell me like a little bit more about that.
Yeah, I think the biggest one is that Kafka, when Kafka became popular, object storages were not that popular yet for like general use. And a lot of what Kafka does is based on how it handles disks and files on disks and every operation that comes with that. And that is super limiting in a high volume, high throughput environment. In terms of like operational proficiency required, it's hard to manage, super hard to manage Kafka. It's very complicated to set it up, and it's very expensive because disks are expensive. But in the cloud world, we have cheap storage available, which might be a little bit slower, but today it's like barely noticeable for like 99% of the use cases, and it's super cheap. So Estuary Flow is essentially if you build Kafka, but instead of disks, the primary and only storage backend that it uses was an S3 bucket.
Okay, which it sounds really familiar with WarpStream, and what I was talking about earlier is Confluent bought WarpStream for those listening.
Exactly.
But, for the purpose that they didn't have this object storage utilization capability. That's super cool. And Gazette so what's the difference between Flow and Gazette? And like, can people just take Gazette and use it and it's just like Flow, or maybe you're going to show us this and we'll find out. But is Gazette the engine and Flow is like the whole platform?
Yeah, so Gazette is like the streaming backbone, very similar to what Kafka is, and Flow is the data integration platform that is deployed as a Estuary Flow and available as a SaaS tool. So Gazette itself is open source. You can check the code if you'd like. There are a few people who actually self-host it and use it in their own infrastructure. It's kind of complicated, and it's not something that we currently have the resources to actively support. But for the brave ones out there, it's definitely possible.
Cool. Well, I would love to see a little demo. I know you had something prepared,
Sure.
so we can see what flow looks like.
Yeah, for sure. So I'll just share my screen, and is it working? Can you see it?
Yeah, I can see.
All right, cool. So as I mentioned, Flow is a unified data integration platform. On one side, we have data sources, and the other side, we have data destinations, and in the middle, we have collections. One of the biggest differentiators that we have between Flow and Kafka based platforms is that we store the data in the middle after we capture all the changes coming from a data source. So if we have like a change data capture data flow setup that constantly ingests data from a Postgres binary log, all of those changes get persisted in the middle in Flow in an object storage that I was talking about earlier. So that makes it super cheap. And from there, in real time, in a streaming fashion, they get materialized into a destination, usually by our connectors. So the DECF setup, the Kafka API compatibility is a little bit different than this because there's no connector on the other end. We just essentially expose the data from the object storage that we ingested.
Okay. What are the guarantees that a user gets between, well, one like internally in Gazette, and then maybe between the sources and syncs?
So for most of the popular CDC sources and data flows, we can do like less than 100 millisecond latency, which we have not benchmarked yet with DECF, but there's barely any overhead in the whole process. So I would safely assume that it's somewhere there as well.
Yeah.
Or even lower.
And in terms of like exactly once or at least once.
Yeah, so exactly once for most of the data flows that are, it kind of depends on some of the connectors on the destination side if we can make it happen, but for like the 90% of the connectors we support exactly once.
Cool.
So the platform itself is pretty simple. You have sources, collections, destinations here on the left side, and if I go into sources, you can create a new capture with just a click, and here you have the gigantic list of connectors that we currently have and actively support. As I mentioned, like the most popular ones are here at the top, like MySQL, MongoDB. We also support Snowflake as a source through its change data capture functionality, and there's like many more in this list. So once you set up a source connector, the connector does a backfill where it gets all the data from that already exists in the source, and then it switches into a continuous streaming replication mode. So now, as a demonstration, I can show that we have a stream that is constantly, continuously running and ingest data from the public Wikipedia API, which, by the way, if anybody wants to build streaming applications, I really recommend this API because it's totally free, it's real time, and it's amazing to test things out and build things with. So yeah, definitely give it a go. Yeah, so this is what we have currently being ingested into Estuary Flow. You can see in this dashboard that it is writing documents continuously every hour. It's like 158,000, 120,000, and these are the number of changes that happen on Wikipedia.
And so a document is in Kafka terms like a record, or in event terms,
yes,
it's an event.
Yeah, exactly. A document is like one record, one event, and a collection of events is what we call a collection.
And where does Estuary Flow run? I see over here like data plane GCP. So is it a BYOC architecture, and you can have a different data plane, and it can be that can be your own data plane, or how does that work?
Yeah, so it is a BYOC architecture. It's separated into a control plane and the data plane. The control plane is the brains of the operation that does the statistic collections, the logging, reporting, all that kind of stuff. But it doesn't actually touch the data, so only metadata. And the data plane is where the data extraction, the data transformations, and the data materialization happen. And the data plane can be deployed into your own private environment, on premises, in your VPC, and then connected to our control plane, the managed control plane, with a private link. So this way, you in a BYOC, through BYOC fashion, you get the best of both worlds, like the efficiency of an internal data plane to your network, and the convenience of a managed control plane.
Cool, very cool.
Yeah, so this data plane is running in the US. You can also choose an EU data plane if you have regional restrictions that we manage as well without you having to do anything. Yeah, so as I mentioned, this recent changes collection is constantly being written into. And if you wanted to use like the traditional way to set up a data flow, you would click this materialize button and then search for Snowflake or BigQuery or some data warehouse like that you would want to load data into, or Iceberg, for example. But because we are going with DECF this time, we don't have to do any of that. All we have to do is go into this admin menu and just create a refresh token that we can use to authenticate our Kafka consumer too. So I have already did this, and I have already configured my Python script here, which is a very super simple example of Bytetalks reading data from a Kafka broker and one topic. So this is where the Kafka API translation happens, because the way you would configure this, or the way you configure this, is exactly as if it was a Kafka broker. Like we expose this address, which is our managed DECF service, and everything else you do is exactly the same as if it was Kafka. You can see here the name of the topic that I'm ingesting or configuring as an input is exactly the name of the collection that I was looking at earlier, right here.
I've got a question while we're going through the source here. Is there the idea of partitions in Flow, or I guess Gazette underneath? Like, how's that handled?
So there are no partitions, and we don't, or whenever a request comes in that actually wants to look at partitions, we just abstract that whole thing away and just keep pushing data into the consumer.
Interesting. So if
that is something that happens in DECF, for example.
Yeah. So if you run with multiple Bytetalks workers, only one is going to receive, or is it
no, I mean, so we do have the way to parallelize the consumers, but it just gets translated into however Gazette handles parallel reads, and it's not partitions.
Okay, cool.
Cool. So for this example, yeah, as I mentioned, it's just reading this topic and doing essentially nothing on it, and then writing it out into the standard output. So if I just execute this very quickly, our expected output is a lot of messages being spammed out because it's starting from the earliest message, and there's probably like billions of messages already in this topic. But yeah, just Control-C and stop. So we can take a look at how it looks like. And I don't know if it's visible, but among all the garbage, you can see that the title, category, and all of the fields are there in the actual value of the messages that we expect.
Someone's editing the Next of Kin film from 1989, which is my birth year. Great year.
Right. There's a lot of edits happening simultaneously on many Wikipedia pages. It's a very interesting data set to look into.
Yeah, it is pretty wild. We have an example too. I think it's like a rite of passage to have like a
I
Wikimedia
think so.
example. Well, that's
The
super
streaming
cool.
hello world.
That's really interesting. It's one thing that also came up when you were talking about the outside of the Bytewax stuff, which um, is great. I'm really excited. I think this is a good opportunity, or it could present a good opportunity for folks who are getting, especially folks who are getting started with real-time processing, or they have like early stream processing demands. Estuaries seems like a very easy to get started thing, and easy to adapt use cases, because you're like, okay, we have one here, we have a downstream tool we can use, we're going to do anomaly detection or something like that, and now we actually have all these other sources, and those can all work in real time or in batch, and it seems like a nice way to enter the whole pattern and ecosystem.
Yeah.
The question I had was, so you store all those documents, is there a retention period?
So the default configuration is that we use our own Estuary bucket to store those documents, and the retention period by default, I think, is a month. But we do have the option to allow you, the user, to provide your own bucket. And in that case, retention period can be infinite. And you can also set the restrictions as well for data privacy and protection. So
Yeah.
you will own that data too. And that's what we recommend most of our customers to do so.
Okay. So is it possible to just query that data directly? Like, so what if I'm using this, I have that data stored in a known format and way the schema is available. Can I query that directly? Is that something that you're
I mean, essentially, it is a data lake, and it is
Yeah.
just a JSON document. So if you know the structure, you should be able to query it. There is a specific structure that Estuary expects, and this is an idea that we toyed with for a while. Like, do we want to expose it as, like, I don't know, like an iceberg table or like Parquet files or something like that, internally and externally. We don't officially support it, but I think it should be possible, for the ones that want to try it out,
Yeah, no, I mean, it's really interesting. It seems to be a trend in the industry to offer streams as iceberg tables. I think both Red Panda and Confluent kind of do that now with table flow, and I don't know what the Red Panda thing's called. Yeah, the whole world is converging, it seems like.
I think so, yeah. How is Bytetalks doing with iceberg?
I actually wrote an iceberg sync the other day because I was working on something. So it works well. I mean, the thing for us is, for most of these, is you get something in an arrow format and you can put it a lot of places. So like once you get to that level, there's so much portability. And because Bytetalks is so flexible, you can collect things and convert it into a arrow table with PyArrow, and then the world is your oyster, as long as you can connect to the thing and you can coordinate mapping progress and how you handle restarts, so you don't have make it idempotent or whatever. As long as you can do that, you're in a really great place. So yeah, I did write one. It's not available publicly, but I will make it some point available publicly.
That's pretty cool. That's pretty cool. It's kind of a shame how hard it is to efficiently stream data into like a Parquet format because of the way it's structured, which is very good for like other use cases, but sadly not as intuitive for streaming.
Yeah. I mean, it's possible to get really good like latency and you can have like a near real-time or real-time experience on top of Arrow, like columnar formatted stuff. Like I know some of the time series databases and some databases that use like Arrow, Data Fusion, and Parquet are able to actually have like a near real-time or real-time, like super low latency, not just in the query time, but in the ingest to query time.
Yeah, for sure. For us, I think one of the biggest challenges when streaming into Iceberg was memory efficiency, because
Yeah.
our connectors run in a memory constrained environment, and the columnar micro batching writes very often just blew up the whole thing. So yeah, we
Mm,
had to do a few tricks there.
yeah. Yeah. Cool. Yeah, is there anything else you want people to know about Estuary or about yourself before we go?
I think these are the most important things. I'm super happy that we're officially Kafka API consumer API compatible, and that enables integration such as this one with Bytetalks. And yeah, I'm just looking forward to seeing what people actually build with these tools.
Yeah. We'll put a link in the video of the blog post. Danny wrote like a very in-depth use case that uses MongoDB and Estuary and Bytetalks. So that will be, people can check that out.
Awesome.
Cool. Well, thank you so much for joining me today.
Yeah, thank you so much for having me. It was great.
Right on.